So why there's a small gap between the phosphorus and sulfur? So phosphorus group 5, sulfur group 6. So and phosphorus atomic number 15, sulfur is 16. When you write electronic configuration for phosphorus, that is 1s2, 2s2, 2p6, 3s2, 3p3. So means the 3p orbital, you can see here, electron will occupy singly. Whereas when you draw for sulfur, write the electronic configuration, it's 1s2, 2s2, 2p6, 3s2, 3p4. So you can see here there will be a pair of electron in the 3p, and that will have more repulsion, so it will be difficult to remove. This will be easy to remove electron from sulfur as compared to that of phosphorus. So with the sulfur, there are 4 electrons in the 3p subshell, and the fourth is, it's starting a doubling, means like there will be a coupling, or the 2 electrons will be in the same orbital, and electrons are like charges, and like charges repel each other. So it will be relatively easier to remove electron from sulfur as compared to that of phosphorus. Is it clear, this concept? Then the periodicity, it refers to like a repetition of the property. Look what happened when you write the electronic configuration for sulfur and phosphorus for p orbital. When we write, for example, phosphorus, which is 15, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. The electron in a box model, so this is 1s, this one is 2s, then 2p, which consists of 3 orbital, then 3s, and then 3p. So how the filling up of the electron take place? Electron initially occupy these orbitals singly, like s maximum can hold 2 electron. So one will rotate clockwise, another one anti-clockwise. They will have repulsion. This can have 2 electrons, so one clockwise. Now 2p is having 6 electrons. So how they fill up? First, initially they occupy singly, and then in opposite direction, the opposite spin. Then 3 is S is having 2 electron, one rotate clockwise, but 3p is having 3 electrons, so they will occupy singly. Because p is having px, py, and pz, 3 division, so they occupy singly. They will have less repulsion. But when we write electronic configuration for sulfur, which is 16, so we write 1s2, 2s2, 2p6, 3s2, 3p4. So that makes 16. So when we complete electron in a box model, and show these electrons. So 1s is having 2 electrons, so means 1 rotate clockwise, 2s having 2 clockwise, 2p is having 6. But how 2p filling up? First they will occupy these singly and then they pair up. 3s clock. Now 4 electrons you have to arrange. So 1, 2, 3, and then there will be a pair 4. So what happened? You can see here that there's a pair of electrons. An electron are like charges repel each other. So if I supply energy, small amount of energy, one of the electron can easily go out. But here, because all are singly occupying, so it will be slightly difficult to remove this electron because they have less repulsion. So here in 3p4, when 3p4 means there are 4 electrons in the p orbital, they have greater repulsion between them, so it is easy to remove the electron. Where in 3p3 they have less repulsion, so compared to 3p4, in 3p3 it will be like in 3p3 it will be difficult to remove electron compared to 3p4. That's why sulfur ionization energy is less as compared to that of, or smaller as compared to that of phosphorus. Is it clear? So basically, what is the periodic table? The periodic table is divided into blocks. The first two groups are known as S block element. Why we call them as S block element? Whenever we write the electronic configuration, their last shell electron is in the S orbital, we call S block element. Group 3, 4, 5, 6, 7, and 8. They are known as P block element because whenever we write the electronic configuration, the last shell electron is in p orbital. Then we have D block element. The last shell electron is in a d orbital, and then F block element. So actually, the whole periodic table elements are classified as S, P, D, and F according to which orbital the highest energy electrons are in. The electron which are having the highest energy, where they are present, that is refers to the block of the element. Then atomic radius or size of the atom. So atomic radius decreases as we move from left to right, means across the period it decreases. Why the atomic radius decreases across the period? Because there are more proton or greater nuclear charge or positive charge, and for the same shielding effect, like example, for sodium 11 proton, for magnesium 12 proton, for aluminum 13 proton. So sodium 11 protons attracting electron in the third shell, magnesium 12 protons are attracting electron in the third shell, and aluminum 13 protons are attracting electron in the third shell. So what happened? Greater attraction. So what we observe, the size of the atom as we move across the period, it will slightly decreases. And down the group, as we go down the group, because there are greater number of shells, the number of the shell increase, the atomic size will also increase. Is it clear? So when we compare the second period, which is lithium, or if you compare the third period, if you take the third period, then it will be sodium, magnesium, aluminium, then silicon, phosphorus, sulfur, chlorine, and argon. When you sketch the ionization energy, the first ionization energy versus the element, so sodium is there. So from sodium to magnesium, it increases. But from magnesium to aluminum, instead of increase, it decreases. What is the reason? The reason is because of shielding effect. So group 2 and 3, why there is a gap between group 3? Why, even though there are more proton but smaller ionization energy? Because of greater shielding effect. Then group 4 is there, group 5 and 6. So group 5 and 6, why there is a gap? Because pairing of electron in the p orbital. And then group 7 is there, and the group 8 will occupy the peak. Is it clear? This is the same thing just now I discussed with you, like the comparison of ionization energy for magnesium and aluminum and phosphorus and sulfur. So you have to learn these points. It is very important to learn how to write the answer related to this question. The melting point, melting and a boiling point, what we observe, the trend in the melting and the boiling point. As you know, sodium, magnesium, and aluminum, these are metals. So metals have a strong lattice of a positive ion and the free electron. So as we move across the period, for sodium, first three element, the melting point increases. Why? Because aluminum having a greater charge, aluminum is all have the metallic structure like positive ion and the delocalized electron, but size of the sodium ion is larger and small charge, so weak attraction. Size of magnesium is smaller, greater charge, so more attraction, higher melting point than magnesium. Then size of aluminum is much smaller. Size should be small and the charge should be great, higher, so that it will have a greater attraction towards the electron. So the melting point increases. So from sodium, magnesium, and aluminum, what we observe, there's an increase in the melting point. Moving from aluminum to silicon, there's a jump. Why? Because silicon group 4 elements are macromolecule. They have a tendency to form long chain compound. So greater number of covalent bond. That's why need more energy. So it will be difficult to overcome this attraction. That's why the highest melting point in this period. Then chlorine, sulfur, phosphorus, they are simple molecules. So you will learn about the type of the forces later in this unit. So they have a weak van der Waals force or a weak force. So it will, that's why they have a smaller boiling point. And argon is also having a weak van der Waals force. So if the question is why from sodium to aluminum, the melting point increase. So this is a reason. Then why silicon is having the highest melting point, then this is a reason. And then why chlorine, sulfur, phosphorus, they have an argon having a low melting or a boiling point, because weak force, so small amount of energy, simple molecule, weak force between the molecule. So small amount of energy can break the bond and change the state. Is it clear, this idea? Now we'll do some questions related to this topic, ionization energy. Okay. In question 3, the first ionization energy in kilojoule per mole for 4 element with consecutive atomic numbers are given. Consecutive atomic number means like one element, if it's 11, then atomic number for other will be 12, then 13 and 14. Which element could be inert gas? Inert gas means group 8. Group 8 should have the highest ionization energy. What could be the answer? So it means, yeah, B is the right answer. Now you have to work out, because what happened as we move across the period, the ionization energy increases. So this 2020, 2080 is group 8 element. And these are successive elements, successive atomic. So means this will be group 7. This will be group 7. This is group 8. And after group 8, if I have another, like the successive atomic number, so after group 8, we'll again get group 1, and then it is group 2. Is it clear how I get this order? Because we identify which one is group 8. The highest one should be group 8. So if this one is group 8, and they mention it is for successive elements. So if this is group 8, so group element A will be group 7. This is group 8, and after group 8, we don't have group 9. We'll have group 11, group 1 element, and then we'll have group 2 element. So the first answer was B. Which element could be X in a covalent compound with a formula XHX, like which is a non-metal and can form a covalent compound? A, B, C, or D? What's the answer? Covalent compounds can be formed by non-metals of, yeah, A is the right answer, because group 7 non-metal will have a valency of -1 and hydrogen is +1. So they will form a compound of HX. Which element could be Y? Ionic compound with a formula of YH2. It means Y should have a valency +2. Valency +2 means group 2 metal. Which one is group 2? So that's D. Is it clear, this question? Because in the question they mention these are energies given for successive element. So first we work out which one is 8. Elements before 8 will be like group 7. An element after group 8 will be group 1 and group 2. Is it clear, discussion? The graph shows second ionization energy. This is second ionization, which could be lithium. So when I draw for lithium, lithium is 3 and 7. It is 1s2, 2s1. When we remove one electron, what will be the electronic configuration? It will be 1s2. Now we want to remove another electron because we want a second ionization. So to remove another electron, it must be removed from the inner shell, which is the first shell. And you can see this matches with helium. So if this electronic configuration matches with helium, helium is having the highest ionization energy. So what could be the answer? The answer will be B. Is it clear? Because we already remove one electron, we want to remove the second electron. So the second ionization energy of lithium will be similar to that of helium, and we know helium is having the highest one, so lithium will also have the peak or the highest one. The first 5 ionization energies, the first 5 ionization energy in kilojoule per mole of aluminum are given. The orbitals from which the first 5 electrons are removed. So when you write the electronic configuration for aluminum, as you know, the periodic table will be there. So it is 1s2, 2s2, 2p6, 3s2, 3p1. So when we remove the electron, the first electron is removed from 3p. Then the electron is removed from 3s. Then another electron from 3s. Then 2p and then 2p. So 5 electrons are removed in this order. So what's the answer? A, B, C, or D? So D is the right answer. Then going across the table, going across the periodic table from sodium to aluminium. So moving from sodium to aluminium, what happened? Like moving across the period. Sodium will be there, magnesium is smaller in size, aluminium further smaller. Melting point increases, that's true. Atomic radius increase, that's wrong. Radius of a metal line increase, that's wrong. The bonding of element changes from metallic to covalent, that's also wrong. They all have metallic bond. So what's the right answer? A is the correct answer. Is it clear? So this is about the mass spectrometer and ionization energy. More questions we will discuss related to this topic so that you have a better understanding of a topic. Next class, I will discuss the questions. Before that, I want you to quickly go through all this. I already shared the presentation with you. So you can go through and we'll discuss this assignment in the class next period. Any question related to the today's class? Okay, I'll end the session and share the recording with you, and we'll continue this mass spectrum and ionization energy assignment next class.